Okay, this is the beginning of chapter 5. So chapter 5 begins an important discussion primarily focused on covalent bonds. We are looking at the difference between these, of course, to begin with. It's important to review. So I highly recommend you do a comparison between covalent and ionic bonds. All right. As just a hint, or perhaps pointing out the major difference, covalent bonds involve the sharing of electrons compared to ionic bonds, which are described as the full transfer of electrons from one atom to another to create positive and negatively charged ionic particles that are then attracted to each other. So we can say the covalent bonds, in general, are the sharing of electrons in orbitals. Now, just like ionic bonds, this is done to try to generally satisfy something akin to the octet rule. And remember, the octet rule says that the atoms want to have a complete octet in their valence shell, their primary outermost shell. So we do that here with covalent bonds by sharing electrons. Remember that you are only allowed 2 electrons per orbital. And so when a sharing occurs, when you have overlap of atomic orbitals between atoms, now, of course, there are exceptions to the octet rule, even in covalent bonds. The most classic example of this is when you have 2 hydrogen atoms come together. Okay, so let's start with that example. If we draw the Lewis structure, the Lewis dot diagram for 2 different hydrogen atoms, like so, you can see that each hydrogen atom, here's one atom, second atom, they only have 1 electron. Now, being in the first period, they only have a 1s shell, which can only hold 2 electrons. So that means when you get orbital overlap between these 2 atoms, like so, we can now consider them to be sharing these electrons. We'll draw 2 electrons between the hydrogens, like so. And this is now that covalent bond showing the sharing of those 2 electrons. Now, we can simplify this electron Lewis diagram to, instead of utilizing a pair of electrons like that, we can draw a single line as a single bond. That single line bond, though, remember, is a pair of electrons. So that single line represents a pair of electrons, not just a single electron. Okay. Now, if you look at helium, helium will actually have a pair of electrons already. And since it is 1s full, in general, we say it cannot bond, which is what we discussed when we talked about the noble gases and we looked at those. Now, I will continue this in the next lecture.